Welcome. This is a short video regarding circuit diagrams, tips, tricks, and some worked examples. I've got 3 tips for you when it comes to creating circuit diagrams in your exams. Tip number 1 is a really important one, and the first tip is to make sure that you master the 6 basic logic gates before proceeding. There are 3 things that you should remember when it comes to the logic gates. The first thing to remember is the logic symbol. So for example, in this, I've got all the logic symbols there, but what I mean is this is the logic symbol. The second thing that you need to remember and absolutely memorize is the corresponding truth table. And the third thing that you need to remember and recognize is the English explaining. The third thing you need to remember is the explanation of each gate. Now, there will be some sort of English representation of the gate itself. For example, if I go down to an AND gate, I would explain it such as that the AND gate is only on when both inputs are on. Tip number 2 is to make sure that the truth tables are filled out in order. Now, this is something that I have seen has caught up a number of students in the past. And what I mean by that is when you're creating your 2 input or 3 input truth tables, you order them as such as if you were numbering binary numbers from 0 all the way to 3 for 2 inputs or 0 to 7 for 3 inputs. So for example, if I was starting to write a truth table out for 2 inputs, the first thing I would put is 0, 0. And then I would be putting 0, 1. So that actually, if I was to put this in decimal, that would equal 1 in decimal. 1, 0, which equals 2, as we know. And 1, 1 is 3. Likewise, if I was to do 3 inputs, make sure that it goes 0, 1, 2, and all the way down to 7. So please, that's tip number 2. Make sure that you put your inputs in order. All right, number 3, there are 6 kind of ways to represent circuit diagrams that you sort of expected. And I'm going to go through them now. So the first one that you should be able to do is to show the behavior of the following circuit with a truth table. So like as I just mentioned, you need to be able to write truth tables. And the first step that you would do to write truth tables, in this case, it's just a 2 input truth table. What I would suggest is to number this in order. So 0, 1, 2, and 3 if I added all those inputs up. The next step I would do is I would then label corresponding outputs. So we have C and D, and Q is normally represented by the final output. X is another way you could represent it as well, but Q is kind of the standard. And so you can see that the C input is A and B, so I'm just going to put that there. The D input is A plus B, and the Q output is C plus D, where plus being an OR gate, a dot being the AND gate. Then we can fill out each column based on the gate. So we know that in an AND gate, the only input that should be on is the last one. And we know in an OR gate that the final 3 need to be on. So then if we were to add all of these to do our final one, we're now concerned with C and D. So we'll see that with an OR gate, as soon as you have an input on, then the output must be on. And so that is the final answer. for number 1. Number 2, in an exam, you may be asked to represent a circuit diagram with a Boolean representation. Now, these shouldn't be too concerning for you. The way I like to do them is to work right to left. So on my left-hand side, I have an input A and inputs B and C, and it's going to an output Q here. So to convert this as a Boolean representation, I firstly need to understand what this symbol is, which is simply a NOT gate. So I would put that here. Now, what I'm doing is I'm actually feeding that NOT gate into an AND gate. So on one side of the equation, on this input, that is my input. Now, on the other side of the equation, for this one, I need to convert this into an XOR gate. So to do that, I would write B plus, and I've got a special symbol there for an XOR gate. And that's it. You can see that to get the answer, I would need to do not A and B XOR C. So that's kind of how you answer those questions. And I might just highlight that just with that little arrow there. All right, the next one is draw a circuit diagram corresponding to the following Boolean expression, A plus B and B and C. Well, again, we're treating each parenthesis as a single group. So I'm going to draw my 3 inputs here. And I'm going to do my first one. I'm going to attack this one first. So what I'm going to do is I'm going to draw an OR gate because it's A or B. And then the next one is going to be B or C. So I'm just going to put a little dot here so that I can now bring that input across. And I'm going to draw an OR gate. And to bring them together, all I need to do is, if you can see here, I've done those two. And because there's no plus in the middle, we know it's an AND. And I just have to put an AND gate there. And so that's it for drawing a circuit diagram. You just take each part of it and work through it methodically and logically. All right, so for this one, number 4, we might be asked to construct a Boolean representation from a truth table and/or then construct a circuit diagram from the given truth table. So we need to think back to our notes, and we looked at this idea of getting a truth table into a Boolean expression can be done through 2 methods. The first method is what we call product of sums. A second method is called sum of products. And then this particular method, number 2, is used when there are, I'll just put this here, minimal ones for Q. What I mean by that is that in this particular case, there are 3 ones in Q. So we would favor this method, the sum of products method. Now, if there was lots of 1s in this column, then what we would do is we would use product of sums instead. So let me just go through the sum of products method, because this is probably the most likely one you're going to get rather than the other way around, because you're more likely to have less outputs on, if that makes sense, less Qs being on. So what you do is you just highlight the 3 or the particular rows that have 1 on. Then the next thing that you do is you need to understand that in this particular method, 0 is represented by a not symbol, and a 1 is just a regular letter. So if we were to extrapolate this now, for example, this one, what this is basically saying is that that is not A. B is just B because it's 1, and C is not C because it's a 0. Likewise, if I was to then do this one, I'm going to be saying, well, that's A because it's 1, and that's going to be not C and not B. And then likewise, this last one, it's going to be A and B and then not C. So that is the Boolean representation for this truth table. However, it's probably then you're going to ask to simplify this because we're going to create a circuit after this. So with the power of technology, I'm going to simplify this really quickly for you now. And that's it. So we've turned this into now a more simplified part. Now, this is now easy to construct a circuit diagram because what we can do is simply say, well, we've got 3 inputs, A, B, and C. The first input is not C, so we can just put a NOT gate here. And that's going into, it's feeding into an AND gate, which is coming from then an OR gate as such. And so there we go. There's the final answer to that question. One that you might get asked is to construct a truth table from a particular Boolean representation. So the first thing you've got to ask yourself is, well, how many inputs are in this truth table? And you can see here that we've got 2 inputs only. Why do we only have 2 inputs? Well, there's only A and B. So we'd draw our truth table and we'd have A and B like this. So you would start setting this out as I've mentioned before. So 0, 0, 1, 1, 0, which is 2, and then 1, 1, which is 3. Okay, so that's the first thing that you do. Then you've got to deal with what I call left to right, right to left, and kind of explain what that means. So the first one we've got to deal with is this one. I'm going to call this input C, but below it, I'm just going to put what it is. And that is A and B. So we know that this shouldn't be too difficult to work out because it's going to be an AND gate. The next thing we've got to figure out is you might be going, well, do I do this one or this one? No, the best way to do them is left to right, right to left. And what I mean by that is we're going to do this one, then we're going to do this one as our next input. So that's going to be a D, but in this case, it's going to be A plus C. Sorry, A plus B. And if we do A plus B, we'll know a regular OR gate will look something like this. So now the next thing that we have to do is we have to deal with the plus in the middle. So we're now going to do the whole equation. So essentially, it's going to be C plus D. And so I'll just bring that down, creating a new input called output called E. And we can just now do an OR gate based on this, and it's going to look pretty much just like an OR gate. And then the final one we've got to deal with is this whole equation. We're finally getting there, and that is our final output. And our final output is essentially E, because this was E in its entirety, plus A. So I'm just going to go this column plus this column. Okay, so that's 0, 1, 1, and 1. And you can see here that this particular equation could be simplified down to a simple OR gate, and you could do the Boolean algebra to work that out. So look, that's just a recap of some worked examples on how to sort of really nail these circuit diagrams.